Students, in the last class we were solving problems in miscellaneous. I have told you whatever the problems we have solved using the properties of determinants and matrix method of solving system of linear equations. Same type of problems we are facing in miscellaneous also. If you have solved all the problems in the textbook well, you can solve the miscellaneous problems very easily. Exercise problems are, that's why they are very important. So we have few more problems left with us. So let us take up the 17th problem. What is given? 17. If A, B, C are in AP, you have been asked to evaluate or prove that x plus 2, x plus 3, x plus 4 in the first column, x plus 3, x plus 4, x plus 5 in the second column, x plus 2a, x plus 2b and x plus 2c in the third column. They have to prove that it is equal to 0. So you know the method. When we want the answer for a determinant as 0, you have to prove either two rows or two columns are identical, or you have to prove that all the elements of any row or column are zeros. That's what we have to prove. So let us take LHS. First row x plus 2, x plus 3, x plus 2a. Second row x plus 3, x plus 4, x plus 2b. Third row x plus 4, x plus 5, x plus 2c. This is what. So let us take the operation R2 dash. R2 minus R1. Remember students, we need to prove the determinant as 0. So what happens when you take this? First row as it is x plus 2, x plus 3, x plus 2a. Second row x plus 3 minus x plus 2 means 1. X plus 2 minus x minus 3 means it is 1. X minus x cancels. 2b minus 2a. Shall I write it as 2 into b minus a? I have taken 2 as common factor. X plus 4 minus, you have R3 dash. Take it as R3 minus R2. X minus x cancels, 4 minus 3, 1. X minus x cancels, 5 minus 4, 1. X minus x cancels, 2c minus 2b. It is 2 into c minus b. So what is given? See here, A, B, C are in AP. It is given. A, B, C are in AP. When three terms are in AP, difference of between the consecutive terms is constant. Hence b minus a is equal to c minus b. So second term minus first term should be equal to third term minus second term. So how this can be written as further? X plus 2, x plus 3, x plus 2a. 1, 1, 2 into b minus a is nothing but c minus b. See here, b minus a is nothing but equal to c minus b. Third row, 1, 1, 2 into c minus b. See, you can see here, second row is equal to third row. You can use the property number 3. When two rows are identical, the value of the determinant is said to be 0. So I conclude determinant value is equal to 0 because two rows are identical. I think you have understood. Crucial step is ABC are in AP. When ABC are in AP, difference between the consecutive terms is equal. Second term minus first term should be equal to third term minus second term. B minus A is equal to C minus B. Substitute it in the second row. So before that you have to take the operation. R2 dash is equal to R2 minus R1. R3 dash is equal to R3 minus R1. Then you will be getting this answer. I think you have understood this problem. We take up one more similar problem. It is given if A, B, C are in AP, prove that 2y plus 4, 5y plus 7, 8y plus a, 3y plus 5, 6y plus 8, 9y plus b, next 4y plus 6, 7y plus 9, then 10y plus c is equal to 0. We have to prove this. This is the problem. ABC are in AP means, ABC are in AP. It is given ABC are in AP, difference between the consecutive terms is constant. That means second term minus first term is equal to third term minus second term. We have studied AP in detail in first PUC. Okay. Now, so let us take LHS here. LHS we have to write it again. 2y plus 4, 5y plus 7, 8y plus 8, 3y plus 5, 6y plus 8, 9y plus b, 4y plus 6, 7y plus 9, 10y plus c. This is what we have. So let us take the operation similar to the previous problem. What we have done? R2 dash, R2 minus R1, R3 dash, R3 minus R2. Now 2y plus 4, 5y plus 7, 8y plus 8. You have to take the row operation, second minus first. 3y minus 2y is y, 5 minus 4 is 1, 6y minus 5y is y, 8 minus 7 is 1, 9y minus 8y is y, it is b minus a. Think you have understood. R3 dash, R3 minus R2, it's y plus 1. 4y minus 3y is y, 6 minus 5 is 1. 7y minus 6y is y, 9 minus 8 is 1. 10y minus 9y is y plus c minus b. Think you have understood how we have got this. Now, I continue further. 2y plus 4, 5y plus 7, 8y plus 8. Second row, y plus 1, y plus 1, then y plus b minus a. What is b minus a? B minus a can be written as c minus b, as a, b, c are in AP. I write it as c minus b. Third row, y plus 1, y plus 1, y plus, it is c minus b, c minus b. Here what happens? Second and third rows are identical. R2 is equal to R3. So when two rows are identical, the value of the determinant is said to be 0. So here you have to use the condition when ABC are in AP, second term minus first term is equal to third term minus second term. Wherever we have b minus a, we can substitute c minus b. Then second and third rows will be identical. The value of the determinant is 0. Please understand, students. First we take up the row operation. Second row minus first row, you will be getting y plus 1, y plus 1, y plus b minus a. I take up third row minus second row. 4y minus y is y, 6 minus 5 is 1, 7y minus 6y is y, 9 minus 8 is 1, 10y minus 9y is y, c minus b. Wherever we have b minus a, we can substitute c minus b. We have got two rows are identical. The value of the determinant is 0. So I have two problems. They are of the same type. I think you have understood both the problems. But remember the condition. When ABC are in AP, second term minus first term should be equal to third term minus second term. I take up the next one. 18th is given A is equal to x 0 0 0 y 0 0 0 z. We need to find out A inverse. We need to find A inverse. That is the simplest problem. So what is the formula for A inverse? 1 by determinant A into adjoint. This is one of the important problems in which we have elements only along the diagonal. So elements on other side, on both the sides are zeros. Now let us take determinant A. Determinant A is x 0 0 0 y 0 0 0 z. What is the value of determinant A now? Determinant A value will be x, y, z. You know why? X into yz minus 0. Minus 0 into anything plus 0 into anything is 0. Now to find out the adjoint A. We need to find out the adjoint A. Let us find out matrix of cofactors A11. First row will be yz. To take up A12 for 0. 0, 0, 0, 0, z, it is 0. A13 for 0, you leave the row and column, it is 0. A21, so what happens A21 for 0, leave the row and column, 0 into z minus 0 into 0, 0. I take up A22 for y, leave the row and column, x into z minus 0 into 0, I will be getting xz. I take up A23, cofactor of 0. You leave the row and column, x0, 0, 0, which is equal to 0. I take up A31, cofactor of 0. Leave the row and column, 0, 0, y0, 0. A32 for 0, sign is negative, x0, 0, 0, 0 minus 0, 0. I take up A33 for z, leave the row and column, x0, 0, y. It is xy minus 0, it is xy. Now, cofactor of the matrix. What is cofactor of the matrix now? Cofactor of the matrix, yz 0, 0, 0, xz 0, 0, 0, xy. This is the matrix of cofactors. Now, what is the adjoint of the matrix? Adjoint of the matrix is, right, take the transpose, yz 0, 0, 0, xz 0, then 0, 0, xy. You want A inverse. What is A inverse? A inverse is 1 by determinant A into adjoint of the matrix. 1 by determinant A. What is determinant A now? Determinant A is xyz into yz 0, 0, 0, xz 0, 0, 0, xy. A inverse is equal to, multiply that, yz divided by 1 by xyz, yz divided by xyz, you will be getting 1 by x, 0, 0, 0, 1 by y, 0, 0, 0, 1 by z. You want A inverse, which is equal to x power minus 1, 0, 0, 0, y power minus 1, 0, 0, 0 and z power 1. This is for A inverses. If you have A as x0, 0, 0 by 0, 0, 0, z, then A inverse will be diagonal again 1 by x 0, 0, 0, 1 by y 0, 0, 0, 1 by z. I think you have understood how to find out this. Probably you have done all these problems. Very simple way to understand these problems. I think you have understood this. If you have understood, we move on to the next problem, which is very, very important for CET and other competitive exams. Write down the problem. It is given A is equal to, what is that? A is equal to 1 sin theta and 1 minus sin theta, 1 sin theta, minus 1 minus sin theta 1. This is what matrix A is, 3 cross 3 matrix. Then determinant A belongs to, that's what the options are given, determinant A. You need to find out what is the value of the determinant A. That is the basic and important question. Let us write determinant A first. 1, first column I write minus sin theta minus 1. Second column sin theta 1 minus sin theta. Third column 1 sin theta 1. You have understood this. Now let us expand determinant A. 1 into 1 plus sin square. I think you have understood this. Minus sin theta into, leave that round column, minus sin theta, you get plus sin theta. plus 1 into, leave that row column, sin squared theta minus sin theta into minus sin theta, sin squared theta plus 1. Determinant A is equal to 1 plus sin squared theta minus sin theta plus theta cancels. We will be getting 0 plus sin squared theta plus 1. That's what we have. What is determinant A now? It is 2 plus 2 sin squared theta. Determinant A is 2 plus 2 sin squared theta. But we have to find out the interval elevation guys. It is given open interval 2, 4, closed interval 2, 4, anything. So, but how to get the result answer? See, here I write one important concept. I write V naught. What is that? Sin theta value always lies between minus 1 to plus 1. It's very clear. Sin theta lies between minus 1 to plus 1. Suppose if you take sin squared theta, what will be the value, the range of values for sin squared theta? 0 less than or equal to sin squared theta less than or equal to 1. So, if sin theta lies between minus 1 and plus 1, sin squared theta value should lie between 0 and 1. You cannot just square it and write 1 to 1. It is wrong. You know, if sin theta value lies between minus 1 to 1, sin squared theta is positive obviously. If sin theta, suppose if a sin theta value is minus 1, what happens when you take sin squared theta? It will be 1 by 2. So its value should be always between 0 and 1. That's very clear. So we are designed to get this value. So what we do here, we multiply throughout by 2. 2 multiplied by 0 is 0. It is 2 sin squared theta. It is 2 only. We are multiplying throughout by 2. Further, add 2 to throughout. 0 plus 2, it is 2. 2 plus 2 sin squared theta. 2 plus 2 is 4. First we have multiplied throughout by 2, then added 2. Why we have done that? To get the answer 2 plus 2 sin squared theta, so that it can be written as determinant A. Determinant A less than or equal to 4. So how this can be written in the interval form? Determinant A lies between closed interval 2, 4, because we have got less than or equal to. If we would have less than only, then we have written it as open interval 2, 4. This is closed interval 2, 4. I think you have understood. Very simple problem. We want the value of determinant A first. We have found determinant A. It is 2 plus 2 sin squared theta. It is very simple. Every student will do it. Now this concept is important because we want to find out the interval in which 2 plus 2 sin squared theta is. We want determinant A lies in the interval. That means determinant A means 2 plus 2 sin squared theta. So to that end, we first write minus 1 less than or equal to theta less than or equal to 1. If we square it, 0 less than or equal to sin squared theta less than or equal to 1. This is very, very important. It is starting first PUC. Sin theta value always lies between minus 1 and 1. And you know, so when we square it, its value lies between 0 and 1. You want to get the answer for 2 plus 2 sin squared theta. So we have multiplied throughout by 2 here. 2 into 0, 0, 2 sin squared theta less than or equal to 1 into 2, 2. Add 2 throughout. 0 plus 2 is 2. 2 plus 2 sin squared theta, 2 plus 2 is 4. What is 2 plus 2 sin squared theta? That is nothing but determinant A. So 2 less than or equal to determinant A less than or equal to 4. Hence we conclude that determinant A belongs to 2, 4, the closed interval. That's very, very important. I think you have understood how to solve this problem. Please understand carefully. So no need to confuse. Very, very step is very, very clear. You need to concentrate on those steps. I think it's very clear for you. Next problem. Use the product. It's very important. Use the product. Which product? 1 minus 1, 2. 0, 2 minus 3. 3 minus 2, 4. Multiplied by minus 2, 0, 1. 9, 2 minus 3. 6, 1 minus 2. To solve is given. To solve. x minus y plus 2z is equal to 1. 2y minus 5z, 3z it is. 2y minus 3z is equal to 1. 3x minus 2y plus 4z is equal to 2. Using this product only you have to solve it. So if you directly write it, what happens? What is A? A is 1 minus 1, 2. 0, 2 minus 3. 3 minus 2, 4. What is x? X is the matrix of variables x, y, z. A is the matrix of coefficients. What is B? Matrix of constants 1, 1, 2. This is matrix method, but it is in different way it is given. But to solve that, you have to use the product. So, this is one part. Okay. What is the product? Let us take product. P 1 minus 1, 2, 0, 2 minus 3, 3 minus 2, 4, multiplied by minus 2, 0, 1, 9, 2 minus 3, 6, 1 minus 2. What is the product now? See. 1 into minus 2, minus 9 plus 12. 12 minus 11, what is that? It is 1. Now, first row, second column. 1 into 0, 0, minus 2 plus 2, it is 0. Now, first row, third column, 1 into 1, 1, plus 3, and first column you can 3. So, 1 plus 3, 4, 4 minus 4, it is 0. I guess, second row. 0 into minus 2, 0. 2 into 9, 18. 18 minus 18 is 0. Next, 0 into 0, 0. Then 2 2s are 4. 4 minus 3, it is equal to 1. 0 into 1, 0. Plus 2 into minus 3, minus 6. Minus 6 plus 6, it is 0. Third row, first column, minus 2. So 3 into minus 2, minus 6. Minus 6, it is minus 18, minus 24, plus 24, it is 0. Next, 3 into 0, 0. Minus 2 into 2, minus 4. Minus 4, plus 4, it is equal to 0. Third row, third column, 3 plus 6, it's 8. It is 3 plus 6, it is 9. 9 minus 8 is equal to 1. What is this? The product is equal to I. Product is equal to I. If I take this as A, take this as B, A into B has become I. When A into B is I, what you can conclude? You can conclude that A inverse is equal to B. What is A inverse? It is equal to B. What is A inverse? A inverse is 1, minus 1, 2, 0, 2, minus 3, 3 minus 2, 4. Its inverse is B. What is that B? Minus 2, 0, 1, 9, 2 minus 3, 6, 1 minus 2. This is what the inverse. I think you have understood. When we took the product, answer is I. 1, 0, 0, 0, 1, 0, 0, 0, 1. When the product of two matrices is I, then one is the inverse of the other. A is the inverse of B and B is the inverse of A. So I write inverse of this matrix is B. So inverse of 1 minus 2, 2, 0, 2 minus 3, 3 minus 2, 4 is B. So this is what A inverse is. Now I can take. What is the solution of this? X is equal to A inverse into B. What is A inverse? X is equal to A inverse. No need to find out inverse of this matrix because we are using this product to find out the value x, y, z now. So here itself 1 minus 1, 2, 0, 2 minus 3, 3 minus 2, 4. It is same here. What is its inverse? Inverse is nothing but directly it is given minus 2, 0, 1, 9, 2 minus 3, 6, 1 minus 2. What is B now? B is 1, 1, 2. Now x is equal to multiply minus 2 into 1 minus 2 plus 0 plus 2. 9 into 1 is 9 plus 2 minus 6. 6 into 1 is 6 plus 1 minus 4. X, Y, Z. Minus 2 plus 2 cancel 0. 11 minus 6 it is 5. 6 plus 1 it is 7. 7 minus 4 is 3. So equate x is equal to 0, y is equal to 5 and z is equal to 3. So if you substitute these values, it will be verified obviously. I think you have understood how to solve this problem. So dear students, in this problem it is given use the product to solve this equation. We have taken the product to get the identity matrix. Product of two matrices is I means one should be the inverse of other. For B, A is the inverse. For A, B is the inverse. So I wrote A inverse is equal to B. So A inverse is this one, minus 2, 0, 1, 9, 2, minus 3, 6, 1, minus 2. From this equation I have written matrix, that is matrix of coefficients, matrix of variables and matrix of constants. So solution is given by x is equal to A inverse into B. We need not find out A inverse because A inverse is directly given in the product. So I have written in A inverse as minus 2, 0, 1, 9, 2, minus 3, 6, 1, minus 2 here into B. I have multiplied to get the value of the x, y and z. It is 0, 5 and 3. So I take up the last problem here. Is given, prove that a plus bx, ax plus b and u, c plus dx, cx plus d and v, p plus qx, px plus q, w is equal to 1 minus x squared into ACP BDQ UVW. We have to prove this. Simple way. We have to use the properties of determinants to prove this. LHS A plus bx, c plus dx, p plus qx. Second row, ax plus b, cx plus d, px plus q. Third row, u, v, w. We need to prove it as another determinant. We have to prove it without expansion using properties. Let us take r1 dash, r1 minus x times r2. Multiply second row by x and subtract. What happens now? First row as it is, a plus bx, c plus dx and p plus qx. Sorry, first row we are operating. A plus bx, see here, a plus bx minus x times ax plus b. This minus x times ax plus b. What happens now? A plus bx minus ax squared minus bx. So what happens? Plus bx minus bx cancels. We get a into 1 minus x squared. Again, c plus dx minus cx squared minus dx. Dx cancels. I will be getting c into 1 minus x squared. So again, p plus qx minus px squared minus qx. Minus qx plus qx cancels, p into 1 minus x squared. Second row, I keep it as it is. Ax plus b, cx plus d, px plus q. Third row, u, v, w. Shall I take 1 minus x squared as common factor? That's what the answer required. 1 minus x squared as common factor. A, c, p. Ax plus b, cx plus d, px plus q. Third row, u, v, w. This is what we have. See, second row we need to get bd and q. How to get bd and q? It is very simple. You take second row operation, r2 minus x times r1. X times r1. So 1 minus x squared. A, C, P in the first row. Ax plus B minus ax, because we are multiplying first row by x. Ax plus b minus ax. Ax cancels, we are left with b. Cx plus d minus cx. Cx cancels, we get d. Px plus q minus px. Px cancels, we will be getting q. What about in the third row? U, v and w. That's what the RHS. So ACP, PDQ and UVW. Please understand this problem. So first we have taken R1 dash, R1 minus XR1. Multiply second row by x and subtract it from first. We will be getting A minus AX squared. A into 1 minus x squared, C into 1 minus x squared, P into 1 minus x squared. Second and third rows as it is. Now we have got 1 minus x squared as common factor from the first row. ACP, AX plus B, CX plus D, PX plus Q, UVW. Now you want B, DQ in the second row. To that end, I have taken R2 minus XR1. Or XR1. First row I multiplied by x. AX plus B minus AX is B. CX plus D minus CX is D. PX plus Q minus PX is Q. So UVW. So that's what the answer required. Students, I think you have understood. I have written the working here on the RHS. Please write down that. It's very, very important. So these type of problems may be asked in the examination. So you need to concentrate on these type of problems. That is the end of determinants chapter, students. I have solved most all the problems in the exercises and miscellaneous problems and worked examples also. Few problems I have given as common. Please remember, as I have already told you, the weightage of 11 marks is there for determinants. There will be one question for 1 mark on expanding the determinant. There will be a 2 marks question on finding the using area of triangle, in which you may be asked to find out the area of triangle directly using the formula half of determinant x1 by 1, x2 by 2, 1, x3 by 3, 1, and 2 mark problem is there. In that you may be asked to find out the area of triangle, and if the area of triangle is given, you may have to find out the unknown value x, or you may be asked to prove that the points are collinear, or you may be asked to find the equation of a line when two join in 2 points. Any one of these 4 types of problems will be definitely asked for 2 marks. Then there will be a 4 mark problems on properties of determinants, which you have solved in detail, including worked examples. So there will be a 5 mark problem on matrix method. So I think you are very much confident of getting 11 marks from this chapter, 12 marks from this chapter, 1 plus, 2 plus, 4 plus 5. So in all the parts, that is part A, part B, part D and part E, the questions will be asked. Please prepare for these problems, and please ask for doubts whenever you meet me. So every week, one day I will be interacting with you, and if you have any doubts, any problems, please come to me, solve the, you can ask any type of doubts in those 2 chapters, matrices and determinants. Matrices and determinants put together, 21 marks will be there. So I have distributed the question paper booklet and also chapter wise arranged question papers from March 2014 to March 2020. So all question paper chapter wise I have arranged 1 marks, 2 marks, 3 marks, 5 marks. Please solve the problem soon after that particular chapter is over, and I will be giving you the question papers also. Question papers, and you have to solve the papers at home and bring it to me. I will evaluate, and wherever that there is some little error, I will correct it. So that's all for the day. So that completes the chapter determinants. Thank you.